Level 4, number 2. Here you have a ramp. I'll just draw it here. And you have this block that's going to slide down the ramp. We have some distances here. I'm going to put 12 meters up here, which is the distance down the ramp. We have 6 meters here, and that gives us a 30-degree angle here. And we have a mu, which I'll just write up here, of 0.2 for the friction. And they're asking us the energy that's lost due to friction, right? So this block is going to slide down the ramp. And if there wasn't any friction and the ramp was super slippery, then we could figure out the total energy at the top of the ramp, which is position 1, and the total energy at the bottom of the ramp, which is position 2. And we could figure that out. But here's the problem. There is friction, which creates a whole bunch of extra steps at first. So the long way to crunch it out is to think about the total energy at position 1 idea and the total energy at position 2, but they won't be equal. There's going to be some reduction, just like in the question with the frisbee, because the friction is taking some away, right? So what you could do is you could write the total energy at position 1 is really going to be the total energy at position 2 plus the energy lost due to friction. So you could create a variable here to describe that. Now here's the other problem. At the top we have mgh only. I'm shortcutting a little bit here. But at the bottom we have ek only, right? Because you've reached the bottom and you've lost your height. And then you'd have this energy lost due to friction. Well, the problem here is the ek is 1/2 mv squared. Could have wrote that in. But we don't know the v. So we would have to set up a big long question where we figured out all the forces acting on this object, resolving the gravity, figured out the acceleration using F net x and F net y, got the acceleration, did some kinematics, and found the value of v at the bottom of the ramp. And that's a lot of work. It's a lot of effort to go through, right? But there is a bit of a shortcut. The energy loss due to friction, if you think about what happens when you slide down the ramp, let me look at it. So if you wanted to go that route and figure out that v, and then put that v back in here, and then work all this out and figure out how much was lost, you should get the right answer, but it's a long way to go. The other approach is to remember that work equals the change in energy. So if friction is causing the energy to be lost, then the work that's done by friction will tell us how much energy changes because of friction. In other words, it'll tell us the frictional energy. Well, work equals force times distance. The work done by friction will be the force of friction times the distance over which it acts. And we have the distance on the ramp, it was 12 meters. So all we really need to do to figure out the work done by friction, which is the energy loss by friction, it's the same thing, work is the change in energy, then we can figure out the force of friction. The force of friction is very easy to figure out. Well, I'll write it right in here. It's mu Fn, and then we would multiply that by our d. So all we really need to figure out is what Fn is. And we can do that pretty easily because we can put our thing on the ramp here. Here's our normal force. Here's our gravity. And we know that Fgy, the y component of gravity, is here. And then this is the normal. So we do a quick F net y only. And we can realize there's no acceleration here, so what ends up happening is we get the normal force. And we have the mu, we stick that in here, we have the mu, what's given, we have the d is 12, crunch it out, and you get your answer. Nice and simple. Now the answer is given as a percent, again, it's 35%. So once you get that number, whatever that number works out to for solving this equation, that number, whatever it is, would have to be compared to the initial energy, the total energy in position 1. And the total energy in position 1 was all height, so you could use mgh1 to get that number, and times 100%, and that's how you change your your value into the 35% rather than just the amount of energy.